Hi Year 11s and 12s. We're looking at the last video for the IB curriculum on species, communities and ecosystems. In this video we're going to be looking at nutrient cycling. There will be more videos when we're talking about the ecology unit. This is a very small video in terms of things. There's only 2 slides of information. And then we're going to go straight into talking about prescribed practical that we're going to be doing this week or the week after in class, which is about mesocosms. For now though, let's start talking about nutrient cycling. So when we're talking about the supplies that are on Earth, like chemical elements, they're limited, or in other words, they're finite. Okay, so we don't have an unlimited source of these. Once we've used what's there, they're gone. So in order for life to continue, and for it to have succeeded so far for 3 billion years, so for living organisms to have been using these resources for 3 billion years, and in order for us to keep using them in the future, it means they must have been recycled, and we do have proof that they've been endlessly recycled. Okay, the whole process of how these nutrients are cycled through the ecosystem starts with autotrophs obtaining inorganic nutrients from air, water, or soil, and they convert them to organic compounds inside their body through either photosynthesis or chemosynthesis, which we talked about in the last video. Once that's been done, heterotrophs then come along, and they'll ingest these organic compounds by basically ingesting and digesting the autotroph, and they'll release inorganic byproducts from this digestion, returning inorganic byproducts to the air, where autotrophs can take them back up again. Okay, eventually those organisms, both autotroph and heterotroph, will die, and that's where saprotrophs will come in, and they'll decompose the remaining matter, okay, and release inorganic matter back into the soil. While they're back in the soil, again, where autotrophs can take them back up. So the nutrients here are constantly being cycled through the ecosystem. Okay, we're going to talk about the different cycles a lot more in the next few units inside the ecology unit itself. But now, just know that these nutrients are constantly recycled and cycled through the ecosystem. Because of this means that ecosystems have the potential to be sustainable over long periods of time. Now, for that to occur, for an ecosystem to be sustainable for a long period of time, it has to have met 3 requirements. The first one is nutrient availability. Okay, now that's met by saprotrophs, ensuring that there's a constant recycling of nutrients. We also need to have the detoxification of waste products. That happens through bacteria. We have certain types of bacteria in an ecosystem that can detoxify the waste that we consider harmful to other organisms. And there also needs to be energy availability. Now we have that because most of our energy comes from the light of the sun. Then we have autotrophs converting that, or photoautotrophs converting that into organic compounds so that energy can be cycled throughout an ecosystem. Okay, it is important to note that energy cannot be recycled. A lot of the times energy is lost when we're growing an organism, or it's being used for the metabolism of an organism. For example, excess heating up an organism. So energy is not recycled, but we are getting an endless supply of energy through photosynthesis from the sun. Now, you're going to do an experiment this week or next week, depending on time availability, on mesocosms. Now, mesocosms are closed environments that allow a small part of a natural environment to be observed under controlled conditions. You're going to do this, like I said, in class. It's a prescribed practical, so it can be examined in the final examination at the end of year 12. Okay, and the skill that we'll be testing is setting up sealed mesocosms to try to establish sustainability. And again, we're going to be looking at that this week in class.